Just a short video on the troubleshooting of a high pressure mercury fixture. This happened yesterday during some testing. One of my 175 watt mercury fixtures. Well, the lamp isn't starting properly. This fixture's already been running for several minutes. And there's banding artifacts because camera frame rate. But you see how there's a diffuse plasma in the arc tube and it's wiggling. It's not supposed to do that. By now the arc should have coalesced into basically a steady discharge right between the electrodes. Also, what's somewhat funky is the top electrode, which it is not wanting to focus on right now. But the arc root is actually at the far end of the electrode from where it normally is. It's actually almost right up against the seal, which is unusual. And yeah, lamp current should not be 0.4 amperes. Steady state, it should be more like 1.5. So yeah, what most likely happened is the capacitor has gone bad, because with these constant power autotransformer ballasts, the capacitor is actually the limiting impedance for lamp current. The ballast just has an inductance in it which forms an LC circuit that's used for current waveform shaping. Because actually with these constant power autotransformer ballasts, the lamp is not running on a sine wave drive current. It's actually more of a square wave, and there's a peak at the start of each half cycle, which is why these ballasts are also called peak lead ballasts. Just as a short addendum, capacitor's bulged, so yeah, cap shot. Gotta replace it. And after replacing the capacitor, that's the kind of startup behavior I'm expecting, where there isn't that swirly artifact in the discharge. Of course, this has been on for less than a minute, so the discharge has not coalesced into a steady stream. However, 1.6 amperes. That's the current that is more along the lines of what you would expect for a 175 watt high pressure mercury lamp. And the mains current, yeah, 0.4 amperes, but again the lamp has just started up. Already at 0.5. And another minute in, and discharge is already coalescing. Because when at steady state, these high pressure mercury discharges are about 1/8 of an inch in diameter, because, you know, high pressure mercury. Even though it's not super high pressure, it's only a couple of atmospheres, but compared to something like fluorescence, which operated, you know, near vacuum, you know, that's what, relatively speaking, high pressure, not something like a grenade lamp like high pressure xenon. And there's the fixture at full run up. Still fixed. Now to get some more 10 microfarad film caps. Because for reference, these 175 watt high pressure mercury ballast, well, this is a tri-rated ballast, so it's 175 watt high pressure mercury H39, 175 watt metal halide M57, and 150 watt reduced power metal halide M107 lamps. Flies and mosquitoes. Fun. Also, yes, this kind of thing does pose an electrocution hazard if you're digging around in this stuff and you don't know what you're doing, or even if you do and there is something exposed, so don't be an idiot. And there's the defective capacitor out of the fixture. See, the bulge is even worse than it appeared initially. 1.86 microfarads. That is not good. It's supposed to be a 10 microfarad capacitor. And now an insulation test. Yep. 690,000 ohms-ish. Just pump it up to 250. It's a 400 volt rated cap. And should we go for 500? Wait. Yeah, it's clamping at 368 volts. Or was. So, that capacitor's not happy. And after that test, 1.85 microfarads. So when the cap potential was clamping to 300 some volts during the insulation test, that was a bit more of the capacitor layers burning away. It's dead. Obligatory cat. Covered in dust, because of course he is. Yes.